Hello everyone. I am Sharath, working as an assistant professor in computer science department, Rajiv Institute of Technology. You're all welcome for this lecture video. In this lecture video, we will discuss regarding a computer networks laboratory program, the very first program with respect to NS2 first program. The question go like this: implement three nodes point-to-point network with duplex links between them. Set the queue size, vary the bandwidth, and find the number of packets dropped. Okay, this is the question. We have to create nodes, and in between the nodes, we have to make a duplex links connection, and we have to set the queue size. Means we can vary the queue size, and we have to see the output, and we can set the bandwidth and vary the bandwidth, and we have to see the output with respect to number of packets dropped. So this is the question. The main objective of this program is to implement the duplex links between the network. The very first thing, duplex links in computer communication modes, we come across three modes. One is simplex mode, off duplex, and full duplex or duplex links. Okay, in duplex links there is a two-way communication at a single point of time. Okay, so this is the overall diagram. We have written the network diagram, assuming this is node 1, this is node 2, and we call it as source 1, source 2, and in between connector is there, that we call it as a router, because a router is used to connect between two networks, and in the another network we have a destination, that is another node. Okay, node 1 we call it as n0, node 2 we call it as n1, node 3 n2, and then the node 4, the destination, we call it as n3. Okay, because three node point to point network within the name. Okay, so when it comes to program in NS2, the very basic thing what we have to do is the program starts with creating a simulator object. Okay, here we have used the word object because NS2 in TCL script we make use of combination of two languages, that is command language and also the object oriented language. Okay, the first line we are going to create the simulator object. So set is a command. Here, since this is uses the command language, every spaces is very important. First the line goes like this: set ns, and within square bracket we will write new simulator, where s is the capital letter, new is a keyword, should be written in a small letter. Here we are creating the simulator class object. Here we are giving the object name as ns. Sir, you can ask the question like this: sir, can we give any name for this ns? Yes, you can give any name for this object. This one you can replace with nss. Okay, nss also find any name you can give this, but usually we use the object name as ns only, where set is the command. So in the first line we have created the simulator object. Okay, next open. In the next thing is here in we make use of two files. One is network animation files and the trace file. Network animation file will be used for visualization purpose, to see how packets is going to drop, all those things, and in the trace file, that will be used to analyze the output. Okay, so we have to open the two files. First is nam file and trace file. Okay, in the first two line we have opened the nam file, and then the next trace file, it is a go like this: set nf, the variable name, open lab, the file name, dot nam, extension should be dot nam, and in the write mode we are opening this, and here $ns represents the content of this object. See, the content of this nf object we are assigning to this simulator object. Here we use the keyword nam trace all. Okay, the syntax go like this: nam trace all. Since this is a nam file, nam trace, here trace file, so only trace. This is the only difference you have to notice. Here we use the variable tf. Okay, here nf, trace file, nam file. Okay, So this is the basic thing every program has to follow: creating the simulator object first thing, and opening nam file and trace file. Next, we have to create the nodes. Okay, here we are creating 4 nodes. Okay, how we create: set n not the name of the node, n not n1 n2 n2, any name you can give. We are just giving the name. First node as n not, second node as n1, third node as n2, fourth node as n3, and $ns node is the subclass, okay, of simulator class. Okay, so like this you are going to create the nodes. Okay, since here only 4 nodes, so we have written separately. If you want to create n number of nodes, we can go for loop also to create the nodes. Okay, so now that is not necessary. Now you just concentrate. This is we are creating 4 nodes. This is how we are going to create the 4 nodes. Okay, see, node 1, node 2, node 3, node 4. 4 nodes we have created. Next, we can give the color and labeling to the nodes. Okay, labeling the nodes. Okay, so this is not mandatory. If you want, you can give the color just to differentiate, and you can label, means you can give the name to the node: source 1, source 2, router, destination, like that and all. Okay, that's why I have made it in a red color. This is not necessary. We can leave this part. Okay, only first you create the nodes. Okay, next, the next thing is, after creating the nodes, between the nodes we have to create the link. Okay, after creating the nodes, we have to create the link between the nodes. Okay, see, between the nodes we have to create the link. What type of link we have to create? As in the question they have mentioned, duplex links. Okay, we are going to create the duplex links. Okay, okay, here $ns, the syntax go like this: $ns. What type of link? Duplex links. If you want to create simplex links, this duplex links word will be replaced with simplex links, like that. Okay, in according to question we are writing. So $ns duplex link. Okay, next, the syntax go like this: from where to where you have to create. From to, from n0 to n2. Here, from n0 to n2, then n1 to n2, n2 to n3, like this: n0 to n2, n1 to n2, and n2 to n3. Okay, 3 duplex things we have created. And the next is, it gives you the bandwidth. Okay, we are setting the bandwidth. Any bandwidth you can give. The link of the bandwidth we are mentioning. This is the bandwidth, and this time represents the propagation delay. Okay, in milliseconds. In the next, we are mentioning the queue type. Here the queue type is drop tile queue, means as the buffer gets full, from the last the packets is going to drop. Okay, assume the buffer size is 10. When the 11th packet comes, okay, the 11th packet is going to drop. That's why the name tile, means at the end, the last the packet is going to drop. Okay, so in these 3 lines we are creating the link, and we are setting the bandwidth and propagation delay, and we should mention the queue type. Okay, here the queue type is drop tile. D and T are capital letter. Here duplex links all should be written in small letter. And from where to where you want to create the link, you write, and you write any bandwidth and any propagation delay. Okay, after creating nodes, after creating the link, then we have to set the queue size between the nodes, queue limit. Okay, what should be the maximum limit between? Set the queue size is nothing but queue limit between the nodes. What should be the queue limit? Okay, the syntax go like this: $ns set queue limit from where to where. Here to here, n0 to n2, n1 to n2, n2 to n3, like this queue limit. And this number represents the packets. Okay, 10 packets from n0 to n2. This node, the queue limit, the maximum queue size will be 10 packets, 10 packets, 5 packets, like this is how you are going to set the queue size between the nodes. Okay, okay, when you have this diagram, it will be easy to write the things, the combination. Okay, n0 to n2, n1 to n2, n2 to n3, like this. Then after creating the nodes, setting the links, creating the links, and setting the queue size, and the next thing is we have to attach the UDP agent to the node 1, 2, 3, and we will attach the null agent to the destination, that is N3. See here, when it comes to network, in the OSI model, out of 7 layers, the two important layers is the transport layer and the application layer. Okay, in transport layer, we come across two protocols, UDP and TCP, user datagram protocol, transmission control protocol. Okay, one is for connection oriented and another TCP is for connection oriented, UDP is for connection less. Okay, and in when application layer, we come across n number of protocols. Here in transport layer protocol we are using UDP, and application layer protocol we are using CBR, constant bitrate protocol. Okay, here in NS2 programs, whenever we use transport layer protocol UDP, and at that time in the application layer we make a combination UDP CBR, means in application layer we will use CBR protocol. Whenever we use here a TCP protocol at the transport layer, then at the application layer we will go for FTP, file transfer protocol. Okay, this is how we are going to set UDP 0. Any name you can give, set is a command, any name you can give. New, we are agent and other subclass is UDP, and we are attaching this UDP 0 to node 1. Here this line means all the properties of UDPs is going to attach to the node 1. All the properties, the content of this object UDP 0 is going to be attached to this node 1, like that. This is with respect to transport layer, this is with respect to application layer. Okay, CBR 0 here, attach agent UDP 0, here we are attaching to this object. This is for second one, third one. Okay, node 1, node 2, node 3. Okay, you just replace the UDP 0, UDP 1, UDP 2. Okay, 0 you can give any name, you can give CBR instead of CBR 0, any name you can give. That is not compulsion that you have to give this thing only. Okay, it's just like a variable name, you can define your own name. Okay, next for the destination, that is our N3, we will attach the null agent. Okay, null 0 we are attaching. Okay, null class object we are going to create, and we are attaching the null class object properties to this destination node. Okay, so these things are very important. Once you're one once you are familiar with this one, you can replace the things. Okay, next is we are setting the packet size, the maximum packet size what it should be. Okay, CBR is 0 means it's nothing but first node. Okay, set the packet size, maximum packet size 500 MB. Okay, this line we are setting the packet size. Okay, next in the next this line we are setting the a time interval of the packets, means the data rate of the packets. Okay, next, after setting the packet size set interval, so next we have to connect the agents. Okay, null agent we are connecting to node 1, null agent we are connecting to node 2, means destination to source, destination to source. Here null 0 we can represent, here null 0 is here. Okay, then UDP 0, UDP 1 means this becomes UDP 0, UDP 1, because from here we are sending, so we are attaching these agents. Okay, to transfer the packets. Next, after attaching, we have to schedule the events, means when it has to start sending. Okay, CBR represents 1. Okay, at this point of time, the packet, the node 1 is going to send the packet, and in the very next point of time, the node 2 is going to start sending, and this is the finish time when it has to stop the sending. Okay, next, after scheduling the events, we will come to this finish procedure. Okay, see in like in C we call with the word functions, whereas when it comes to object oriented or in Java and all, we call with the word methods, like that. Here we call with the word procedure. Okay, the name of the procedure is finished. This is the syntax you have to follow. proc, finish, open, close, immediately open. Okay, then we are declaring the way all these objects ns, nf, tf. This is here you have created ns, nf, tf, and flush trace means you are deallocating the object of this ns memory, deallocating the memory, and we will execute this lab1.nam file, and we will close these two and exit of 0. Okay, this is the finish procedure for each and every program we are going to write. This finish procedure you can write here also after creating nam and trace files. Before creating nodes you can write here also, or else we can write here also. Okay, no problem. And ns $ns run means it's going to start the simulation. It means it runs the simulation. This is with respect to the program 1. Okay, this is how all these things we will type, and we will save it as .tcl. Okay, with the extension. Then when we execute this, we will get the network animation window, and trace file we will get. Okay, through network animation window we can see how packets is going to drop, and using trace file we can analyze how many packets are dropped. But in practically analyzing the trace file is very difficult, because in trace file we will get like this around 12 fields we come across. Not around, exactly 12 fields we come like this. 12 fields we have. Okay, each field represents its own meaning. Okay, the first field represents event, means as we know ns2 is a event driven simulator, because when it comes to simulator we come across two types of simulators: event driven and time driven. Event driven means with respect to event it is going to work. Time driven means with respect to time. Means in event driven it's give importance for the completion of the event, whereas in time driven simulator it gives the importance to the time. See, for example, from Asan, if I want to reach Bangalore, that is my event. Reaching the Bangalore is my event. At here we are least bother about the time. At any point of time I have to reach the Bangalore. When I reach the Bangalore I say event is complete. Okay, whereas same thing, whereas when it comes to time driven simulator, suppose I want to reach the Bangalore from Asan. Okay, in 1 hour. Okay, assume in 1 hour I have to reach. Suppose in 1 hour I could not reach the Bangalore, then the simulation is going to stop. Okay, it will work only for 1 hour irrespective of the destination, whether we have reached or not, like that. Okay, here event. Okay, here for words we will get r plus minus d. R means receive, plus means nq, dq, d means drop. Okay, second field is indicates the time at which event occurs. Third field like this is the explanation. You can go through this, the what the field represents. Okay, the 11th field gives the sequence number, and the last field gives the unique ID of the packet. Okay, the fifth field gives the packet type, like that. In output you will get like this. Okay, 12 fields. D means packet drop. Okay, this. See, we will write one more script called AVAC script with the extension of file extend .avk, because we cannot analyze the trace file. So we give the trace file as an input to the AVAC script. So AVAC script will make us too easy to analyze the trace file. So it will go like this: begin, the keyword we have to write like this only: begin, open immediately followed by open flower brace. And here we are using one variable count equal to 0. We are initializing the value 0 to the variable count. Okay, if, and we will check if $1 means first field is equal to d. Okay, here if it is equal to d, then it means that packet drop. As we know, d means drop. Okay, okay, if equal to d means we will increase the count, or else count will not get increased. Okay, like that, up to the end of the trace file it will count, and we are just displaying the total number of packet drops due to congestion equal to percentage. We will get some integer value here. Okay, with respect to this count variable. Okay, this is regarding AVAC script. Okay, while executing, as in the question they told, vary the bandwidth and vary the queue limit or queue size. Okay, so in one first time you set some bandwidth, any value you can give, and some you give some queue limit, and you check the number of packets drop. Okay, second time you change this value of bandwidth. Okay, here here you change the bandwidth value like this. Okay, here 1 2 3 3 values you change, and here also you can change the queue limits. Okay, okay, change the queue limit. Okay, 3 queue limits. Okay. Any value you give, no problem. Okay, any value you give and change, and you see the number of packets stopped. Okay, here you can note these things based on bandwidth and queue limit. The number of packets stopped will be vary. Okay, thank you all. This is regarding first program of network laboratory. Okay, thank you.